I'm Landon Schlangen, and today we're going to take a look at the Celestial Bodies database. This is part of the relational database beta part of FreeCodeCamp. And for this project, we'll build a database of celestial bodies using PostgreSQL, pretty much the same as the Mario database. But I haven't done this one yet, so we'll see what it is. Make sure to have a GitHub account, and then we can get started. So let's start this project, see what comes up. Yep, we want to run with CodeAlly. All right, we have our code road thing up, and let's take a look at it. Let's try and make this as big as possible. Let's see if I can zoom in a little bit too. Maybe that's a little too much. Let's go right there. All right, instructions for this project. You need to log into PostgreSQL with PSQL to create your database. Do that by entering PSQL username FreeCodeCamp, DB name Postgres in the terminal. To bring up the terminal, we can do control backtick. That brings up our terminal. And let me bring this down a little bit. All right, so we need to do PSQL, username FreeCodeCamp, DB name Postgres. Let's do that. PSQL -- username equals FreeCodeCamp and DB name equals Postgres. Make all the tests below pass to complete the project. Be sure to get creative and have fun. Okay, so I guess we just scroll down. Oh, and we complete these tasks below. Okay, so they're not giving us like the exact commands we need to run. We just have to figure it out on our own, which hopefully I can do that because I have been working with SQL for a while. So hopefully I actually know what I'm talking about or know based on experience. All right, here we go. Now we are in. We got our Postgres little prompt and we need to connect to it after we create it. What database do we have to make? Here's some ideas for other columns and table names. Okay, notes: if you leave your virtual machine, your database may not be saved. You can make a dump of it by entering pg dump cc inserts -u FreeCodeCamp universe.sql in a bash terminal, not the PSQL one. That's important to know. It will save the commands to rebuild your database, and then we need that for FreeCodeCamp. Anything inside the project folder, the file will be saved in the VM. We can rebuild the database by entering this. If you are saving your progress on FreeCodeCamp after getting all the tests passed, follow the instructions above to save a dump of your database. Save the universe.sql file in a public repository and submit the URL to it on freecodecamp.org. Okay, so we need to put that in a inside of our GitHub repository. Okay, let's do that afterwards. Let's just start completing these tasks. How about that? All right, complete the tasks below. We need a database named universe. All right, that's pretty simple. We can just do create database universe, and make sure to have the semicolon at the end, and that should create that. Awesome. And now we can connect to it with \c, and we will just type in universe. There we go. Now we're connected to the database universe as user FreeCodeCamp. Perfect. All right. Then we need to add tables named galaxy, star, planet, and moon. Each table should have a primary key. Each primary key should automatically increment, so make it a serial. Each table should have a name column. You should use the int data type for at least 2 columns that are not a primary or foreign key. Okay, you should use a numeric data type at least once. Use text data type at least once. Use Boolean data type on at least 2 columns. Each star should have a foreign key that references one of the rows in galaxy. Each planet should have a foreign key that references one of the rows in star. That makes sense because stars have, or a galaxy has many stars and a star has many planets. That's how they're thinking of it. And each planet has many moons. So there we go. Each moon needs a foreign key as well. Our database should have at least 5 tables. Is this 5? 1, 2, 3, 4. No. Star, galaxy, planet, and moon. That's only 4. Each table should have at least 3 rows. The galaxy and star tables should each have at least 6 rows. The planet table should have at least 12 rows. Moon table should have at least 20 rows. Okay, so we just have to add data into these, looks like, as well. Galaxy, star, planet, and moon tables should each have at least 5 columns. At least 2 columns per table should not accept null values. Okay. Well, yeah, not null. At least 1 column from each table should be required to be unique. Okay. Well, primary key should take care of that a little bit, right? All columns named name should be of type varchar. Okay, yeah, obviously. And then each primary column should follow the naming convention, table name, and then the ID. Okay, so moon should be moon ID. Each foreign key column should have the same name as the column it is referencing. Okay, that makes sense. All right, well, let's start this. We need 5 tables? They only have 4 listed. The fudge, man. Yeah, whatever. Let's just make these 4 for sure. All right, so we need a galaxy table. All right, so we're going to go create table, galaxy. And then inside of here, we're going to have the galaxy ID. Galaxy ID. And this is going to be a type of serial. And it's going to be the primary key, not null. Okay. That's pretty straightforward. Do we want to add anything else? What else does a galaxy have? I don't know. Size. Size will be an int or numeric. Uh, that are not a primary key or foreign key. Oh, yeah, sure. Size. I don't know. What should we do for a galaxy? Speed, maybe? Yeah, sure. Speed. This is an int. And then have a numeric data type at least once, a text data type at least once. We'll do a description on it, sure. Description, which is the type text. Also, you can't see that. Let's just move this up here. I think that's fine. Type text. All right. And let's just do that for now. And those can be null. Those are nullable. See if that creates it. Awesome. That creates our table. We can do \d to view what we have for tables. We can do \d galaxy to view what we have inside of there as far as rows go. So that looks like it was created correctly. All right. And all right, let's make our other tables. So let's make our star table and also reference the foreign key. Um, although we might want to do that with alter statements, actually. Actually, how do we do that? Let's go Postgres foreign key on table creation. Let's look that up quick. Foreign key, create table. Here we go. We can do primary key and then constraint is just added right at the end, looks like. Constraint, FK key, foreign key. Okay. So we can have this as reference. That's good. And let's create our table again. That's actually, can I do that? Let's go here and move this over. Right here. There we go. Maybe that will be better. Let's move this over here. Hey, look at that. Beautiful. Yeah, let's go like this. There we go. So now we have this as reference. And we can create our beautiful star. Yeah, create table, star. And then this is going to have a star ID, which is primary key. And yeah, we can do serial first, or we can say primary key first. I don't think it really matters. Serial, not null. And then we need, what else do we need here? Okay, we can add a size, sure, which is an int. We can add a circumference, or maybe not size, maybe mass. No, let's do circumference, sir. Sure. Circumference. I don't know how to spell. Let's just do radius. Radius, int. And radius is not null. Let's just do that. Let's make that not null. Let's do the color. Sure. Color, which is going to be a varchar. Oh, and also they all need names. Damn it. Forgot about that. Color is going to be a varchar. Varchar, let's just do 255 because why not? 55. Um, not null. And let's add a name, which is a varchar of 255 and not null. All right, that should be fine. Now let's do our foreign key constraint. So we need to do, so we have our contacts and we can just do primary key contact ID. Oh, they just add that as the constraint I see right there. But we do that in our definition, so I think it should be fine to just do constraint. Constraint, and we're gonna go FK of the galaxy. Yep. And then foreign key. Foreign key is going to be our galaxy ID. Galaxy ID. And then it references our customers table, customer ID. Yeah. Foreign key customer ID. Okay. So this references Galaxy and the Galaxy ID. Galaxy ID column. All right, let's try this out. And then I need another parenthesis and a semicolon. Ah, shoot. I did something wrong. What did I do wrong here? Oh, and maybe I do need serial first. Okay. Turns out I do need serial before that. All right, let's fix that quick. Let's go serial primary key. Primary key. Okay, now I think it should be fine. Let's try it. Nope. Darn it, man. What am I doing? Color, varchar, not null. Syntax, error, at or near, parenthesis. Okay, I must have my parentheses wrong. Constraint, foreign key, galaxy, foreign key. This is galaxy ID. Star, serial, varchar. Oh, I forgot to add a space, I think, right here after name. At least that's what I think. Space. No. Space. Okay, now let's try it. Galaxy ID referenced in foreign key constraint does not exist. Are you serious? Let's go \d galaxy. Galaxy ID. Yeah, it does. What the heck, man? What the table is this called? Yeah, it's the galaxy table, right? Yeah. The fudge. Galaxy table. Foreign key, galaxy ID. Oh, I need galaxy ID somewhere in the table as well. That's why. All right, let's add that right here. All right, let's go galaxy ID, which is an int, and then we add the constraint afterwards. There we go. Now it created it. So backslash d star. And there we go. Here's our beautiful star table. We got our star ID, radius, color, name, and galaxy ID. And then we have our foreign key constraints. Awesome. And I also have to add a name to the galaxy as well. So let's go alter table, add alter table galaxy, add column, we need to add the column name, which is going to be a varchar. Varchar 255 not null. Let's add that. There we go. \d a galaxy again. See what it has. And there we go. We just added our name. Awesome. All right. Now what do we need? Automatically increment, yeah. We need our planets. We also have to add a numeric, right? Numeric data type and a Boolean data type. So if we can add that to our planet. All right, so let's create this table. Create table, planet. And this is going to have a primary key, which is planet ID. Planet ID, serial, primary key, not null. And then it's going to have, what else should it have here? We need the name, right? Which is going to be varchar 255, not null. And then we need a numeric. So what can we make that's numeric? Amount of people. Sure. We'll go amount of people. Numeric. Wait, no. I think numeric might be a decimal. I'm not sure about that, though. Ah, whatever. I don't care. We can have half a person, right? There's so many bad jokes I can make about that. I'm gonna refrain. Okay. Numeric. It can be null, sure, whatever. And then we need to add our foreign key and also maybe a Boolean. So Boolean, what should we make our Boolean? Time travel, sure. Time travel, Boolean. Do we have time travel or not? And this is going to be default of false, default 0, not null. I don't know if it's 0 or if it's like actually false. Not sure. And we need it on 2 columns, whatever. We can do that for the next one on moon. All right, and then we need to add our foreign key constraint. So that's just great. All right, so how do we add this foreign key constraint again? First of all, we need the uh, star ID. Yeah, star ID, which is an int, not null. I would say not null. So planet needs to have a star, right? Yeah, right? The planet needs a star. I'm going to say so. Not null. And then we need to add our constraint. So constraint fk star ID or fk star. Let's see here. Come back to me. I need the help. Not this. Wrong thing. Wrong thing. I need this thing here. There we go. Okay. So on this, we need our constraint. What did I do? Oh, shit. I fucked it up. Oh, there we go. Constraint fk star. There we go. Foreign key. Foreign key is star ID. References. The star ID column. There we go. Let's try it. I forgot to add. Oh god. Parentheses, semicolon. Column time travel is of type Boolean, but default is of type integer. Rewrite or cast it. Alright, so it does have to be false. Great. Alright, make the 0 into a false. And let's try it now. Hey, it created it. Let's go. Let's go, bro. Alright. Let's see what we have in this now. Alright, \d planet. There we go. There we go. Planet ID, name, amount of people, time travel, and star ID. And then we have our index and our foreign key constraint. Awesome. Now let's make our moon. All right, so create table. Once again, moon. And inside of here, we need a primary key, which is moon ID. Moon ID is serial. Primary key, not null. We need the name, which is a varchar. 255, not null. Could also have a default on it of like moon. I don't know. It also, we need something to be unique inside of here. What can be unique of a moon? Um, I guess the name could be, or let's do like code. So name code, maybe. Name code is a varchar of 255, and it's unique. Sure. Because we need something that's unique. What else do we need? We need numeric at least once, Boolean of 2 columns. All right, so we need another Boolean type. We'll say is has water. Has water, baby. That's gonna be a Boolean, and it's gonna default, or let's just say not null. Yeah, has water, not null, and let's add that foreign key. So the moon is gonna have a planet as its foreign key constraint. So planet ID, because it belongs to a planet. Planet ID is an int. We'll say it has to belong to a planet, not null. And add the constraint. So constraint is going to be fk planets. And then we're gonna say references. Oh yeah, foreign key. Foreign key of star, wait no, moon, wait no, planet ID. Planet ID. References, the planet ID column. Yeah, hopefully you guys follow that. Let's try creating it. Never mind, I did that wrong. Let's just restart that. I need parenthesis. There we go. Create table, awesome. All right, so backslash d moon. All right, so we have our has water, name code name, which is, this one should be unique, nullable. Dang it. I don't think it's unique. Shoot. Ah, can I alter table? Alter table, remove, alter table, moon, remove column, name code. Shoot. How do we do this? Maybe it's delete column. Is it delete column? Hopefully it's delete column. Oh, drop column, maybe. Drop. Yeah, there we go. And let's create that column again. Table, moon, add column, name, code, varchar, 255, unique, not null. There we go. Now let's try this. And it doesn't really say unique, does it? But, oh, maybe it does. Here we go. Unique constraint. There it is. Awesome, 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 awesome. All right. So we need each star should have a foreign key. Oh, yeah. Did we add a foreign key to that? I think we added all our foreign keys. Our database should have at least 5 tables, though. So we need another table. Look, what else can we add? We can add like black holes, maybe? Sure. Sure, bud. All right, let's create that. Create table. Black hole. Yeah, black hole. And this will be the black hole ID. Black hole ID, which will be a serial. Serial. primary key, not null. And then it's going to have a gravitational pull, sure, gravity, which is going to be an int. And then we'll leave that nullable. Well, what else can we add? It's part of a galaxy. Wait, no, is it? I don't think it is. I think actually, or do galaxies have a black hole at the center of them, right? So it kind of does have a galaxy in a way. Um, yeah, so we'll just add galaxy ID, but I don't want to reference it. I'm just going to say it's an int and it can be null. Sure, whatever. Let's see here. What else can a black hole have? Um, wormhole can be true or false, maybe. Wormhole. So it'll be of type Boolean and it will defaults to false. Defaults false, not null. Sure. All right, so there's our beautiful black hole. Awesome. All right, so \d, that's all our tables and sequences. So we should have 5 now. 1, 2, 3, 4, 5. Awesome. And then we have to add data to these things. We need to add 12 rows to our planet table. Galaxy and star tables should each have 6 rows. So let's start with our galaxy. What do we have in our galaxy? \d galaxy. We have our speed that we need, and we need our description, or we need just a name, actually. The other stuff can be null, so that's fine. All right, so let's insert into galaxy. We just need our name because I want to do the least amount of work as possible. Values. And let's just add a name here. So, I don't know, Andromeda. And end that off. Hey, it inserted. So now we can do select all. Select all from galaxy. There we go. We have our one thing in here, which has a name. All right, so let's add another one. I don't know names of galaxies, man. I'll just say galaxy number 2. You like this, Galaxy 3? Is this good data for you? Hopefully it is, because this is all I want to do. All right, there we go. Now we have 6 of them, right? All from Galaxy. And yep, that's 6 of them. We have 6 IDs here. Awesome. Now we need a \d stars. Yeah, star. So now we need stars, and we actually have to add a lot of stuff to these. So, okay. All right, so let's create star. Wait, no, not create. What am I doing? Insert into, and that was my other computer. Insert into star, and this is going to have a radius, which is an integer, but we don't have to specify that right now. Color and name. All right, values. Also, it should have a galaxy ID. That should really not be null. Yeah, galaxy ID. Because star does belong to a galaxy every time, right? Yeah. All right, so we're gonna go values, and we're gonna add these values in. So we need a radius. We'll just go with, I don't know, a large number. How many miles across is it? A lot. How about light years? Probably, maybe not 1 light year. Yeah, I think it's probably not. A light year is pretty freaking far. Okay, let's go. I, I don't know. Let's just fucking random number. All right, color. is going to be red. And then we need a name. This one's called Beetlejuice. There's actually a star named Beetlejuice out there. Beetlejuice. All right. And the galaxy ID will be number 1. And there we go. Inserted it. There we go. Select all from star. Make sure it's in there. Yep, it is. And now let's add a couple more. Let's name this one Joe. I don't know, bro. I'm so bad at naming things. Let's go yellow. There we go. Let's make this one named Gary. Let's name this wonderful star Big Yellow. Sure. We'll make one orange. And this one will be small orange. And let's maybe give one a different galaxy. And this one will be called Star in Galaxy 2. Sure. Awesome. So now how many stars do we have? We have 6. Awesome. Okay. Time to move on from that. Now let's start making planets. Oh my gosh, now we need 12 planets. Each table needs at least 3 columns. Oh, yeah. I think we did. I think we did you. Yeah. And oh, but these ones each have at least 5 columns. Oh, shoot. Well, we can add those later, I guess. They'll just have to be not null. That's fine. Or just be nullable. Or have a default value. That is fine as well. All right. Let's add some rows to our planets. All right, so let's see what our planet is. \d planets. All right, so we have our name, which is not null, time travel, and star ID, but time travel default, so we don't have to do that. But we do need name and star ID. All right. So insert into planets. We need name and star ID. Values. First one is going to be Earth. Earth, our star ID is going to be 1. And that's awesome. Okay. Let's add another one. This one will be Mars. Let's add another one. We'll add Neptune. See how much I know about my galaxy or my solar system here. I think I know quite a bit. Jupiter. All right. Let's see. We have Neptune that I already did. Uranus. Uranus. I don't know how to spell it. Whatever. Uranus. Uranus. Awesome. Venus. The first one is Mercury. Mercury. And then we have Saturn. Saturn. I think that's all of them in our solar system, right? I guess we could add Pluto, because why not? Apparently not a planet though. Yeah, is that all of them? I think it is. Okay, so now we get to name up our own planets. This planet will be called YOLO. Probably shouldn't have given it our star ID. Probably should have given it something else. But whatever. I guess it's fine. We'll go planet number 2 for um, Jalala. Jalala, sure. And then we'll go planet number 2 for Malala. Malala. Just a bunch of gibberish. Planet number 3 for Pento. Awesome. All right, select all from planets. See how many we have. 13! Hey, we're overachievers, baby. We only needed 12. All right. We need a moon table that has at least 20 rows. Okay. Oh, God. Why? Why? What is our moon called? It's just called moon, isn't it? Insert into, actually, what do we need for moon? Backslash D moon. All we need is, oh God, actually a lot of not nulls here. Name, has water, planet ID, name code. Oh, great. Why did I do this? Insert into moon. We need our name, has water, planet ID, and name code. Values. The name of this one will be moon 1. Okay, yeah, let's just do that. Has water. True. Sure. Planet ID will be number 2, not Earth. And then the name code will be also moon 1. And let's make that. All right, so that inserted correctly. Do moon 2 now. And this one will be a planet 3. We'll do planet 4 for moon 3. All right, and then we'll go moon 4 and just have that as unique value. Sure. Moon 5. I know this is kind of bad data, but I'm just trying to be a little quicker here. 8, 9, 10, 11. Ah, gosh, I forgot 11. Go 11. Go 13, 14, 15, 16, 17, 18, 19. And just to make sure, I'll just add the number 20 here. Let's see how many we have. Select all from moon. Oh, sweet, I have 20 of them. Okay. We do have at least 20 rows now. And now, at least 2 columns per table. Oh, 2 columns per table should not accept null values. Oh, okay. At least 1 column from each table should be required to be unique. I'm pretty sure that's the primary key. Hopefully that works. It's gonna be annoying when it doesn't, though. All columns named name should have type varchar, yep. And then we did that correct, and we also added foreign keys. Yeah, okay. So we just need to make sure that our tables have the right columns, and they all need at least 5 of them. So galaxy, backslash D, galaxy. How many columns do I have on this one? 4, right? Yeah, I only have 4. Okay, so let's add one. Alter table, galaxy. All columns. Okay, we need 2 columns per table should not accept null values. Okay, good thing we do have that. We have the name and the galaxy ID, so hopefully that's fine. Better be. It better be. And then should I leave 3 columns? Okay, so we just have to add a column on this, whatever we want. All right, add a column. What should we have here inside of our galaxy? Rotation speed, sure, int, and we can do not null, default to 100,000, sure. There we go. So now if I do select all from galaxy, all of them should have 100,000 for that value. Oh gosh, select all from Galaxy. There we go. Yep, all of them have 100,000 for that rotation speed value. And then let's see what we have in our star, \d star. We have 5 columns already, so that's good. So that one should be fine. \d planet. How many do we have here? 1, 2, 3, 4, 5. Good. \d moon. And we also have 5 for a moon. Okay, so hopefully this all works fine. Okay, now how do I export this again? We have to do this pg dumps thing. Yeah. All right, so to do this pg dumps, we have to add a new terminal. Now we're in our bash again. And we can just do pg dump cc inserts this. It will save the commands to rebuild your database in universe.sql. The file will be located where the command was entered. If it's anything inside the project folder, the file will be saved in the VM. Rebuild the database. Okay. If you're saving on FreeCodeCamp, follow the instructions above to save a dump of your database. File in a public repo and submit the URL to it on FreeCodeCamp. All right, so let's do this pg dump command. Pg dump -cc inserts -u FreeCodeCamp universe greater than universe.sql. Yeah, see what happens. All right, so now in our files, oh, look at that. We have universe.sql. Let's go. Okay, so now we can add this to our repo. Yeah, we need to add it to our GitHub. Okay, so in a public repo and submit it to FreeCodeCamp. Okay, so let's do that. Let's go to my GitHub, which should be on here. Yep, there it is. All right. And let's create a repo. Repos. Let's do new. This will be FCC, Postgres, Celestial. I know, Universe DB. Yeah, there we go. And it will be public. Sure. Let's not add a README and let's just create this. All right, so now we have to do our git commands. Hopefully they have git installed on this dang thing. I'm just gonna grab this git remote at origin part. Okay, let's do, actually, yeah, they already have git enabled. So I don't have to do git init. Git's enabled, I know that because this is added here in source control. So I think I can just do, what can I do here? Hopefully I can do git remote at origin. Oh, shoot. I can't do from clipboard. Retry. Unable to read from clipboard. Make sure you have granted access for this website to read from the clipboard. Okay, how do I do that? Okay, it doesn't it doesn't tell me. Darn it. Oh my gosh. Are you kidding me? Okay, well then let's kind of do the same thing that we did with this thing. Let's see here. Let's go there, and then we need this. Why is it not showing up? That's annoying. Oh, actually that did do it right. Okay. All right. So we need to do, let's try this git remote add origin. Git remote add origin. https://github.com/landon345/fcc postgres universe db .git. All right, let's try that. Okay, it seems like it added it. Let's try this git add all, git commit. -m, and we'll say initial init commit. All right, awesome. Now let's do git push, see what happens. And awesome, git push -u origin master. Yes, I need to sign in. What the what is this? Oh my, are you kidding me? Oh, here we go. Username. And then 345. Password. Hopefully I don't lose my progress. I should probably like copy all this into my own file. That might work actually. Yeah. And also I spelt it wrong anyway. Okay, awesome. So let's just grab this and then we'll just add a file. Can I add a, yeah, create a new file. All right, so let's paste this in here. Let's name our file universe.sql. There we go. And let's just commit these changes. Yep. Create universe.sql. All right, commit it. There we go. So now I should be able to just add this repo. All right, so let's add this and let's go to our FreeCodeCamp and let's paste this in here. You must complete the project first. Oh, I didn't realize that. Okay, well then let's run this. Oh, shoot. Each table should have at least 3 rows. Yeah, I need that for the black hole one. But the unique one, oh man, that's gonna be kind of hard to fix. Oh, it's annoying. Shoot. Um, I should have made the name unique on all of them. Oh, man. Are you kidding me? Well, and the other one I missed was each table should have at least 3 rows. Yeah. Okay. Okay, so let's first alter table. Or I cannot alter column. I think I can alter column, actually. But let's look at \d of our black hole table. And okay, so I'm gonna I'm gonna add a name to this. Yeah, alter table black hole, add column, and we're gonna add the name, which is gonna be a varchar 255, not null unique. All right, there we go. And now it should have that, yep, unique constraint in there as well. Awesome. And now we can insert some different values. Insert into black hole. And then we need a wormhole. Actually, that's not null, but it defaults, so we're just going to add name, values, bh1, yeah, bh1, bh1, bh2, bh3. All right, so let's try running this again. It should pass that one now. Yep, okay, so it passes that one. And now we just need at least one column to be unique from each table. So I would want to make that the name for each of them, right? So I think I might be able to do that actually. So let's go \d galaxy. And I think, how do I alter columns? How do I alter columns on this? Alter column Postgres. Add unique constraint to column Postgres. All right, looks like this works here. Let me just put this over here for reference. All right, so we have to go alter table galaxy. add constraint. Our constraint name will be name unique, and we'll go unique of name. Yeah, there we go. So now that should be unique. Yes. So our name unique constraint is on the name. Awesome. Let's go. All right. Now we just have to do that to our other columns as well, or other tables. So let's add that to star. Name unique already exists on star, I guess. All right. Really? \d star. No, it doesn't, does it? What the heck? It doesn't. Alter table star add constraint. Oh, it has to be a different name. Okay, so name unique star. There. All right. Let's add another one to our planets. Planets, add constraint, name unique planet. There we go. So now let's try running this again, see if it passes all these. Oh, let's go. Tutorial complete, baby. Congratulations. Continue. All right, you've reached the end of the road to go down another path. Okay. Let's go here. I actually have to dump this again, I think, and then redo this. Okay, so let's do that. Get this thing out of my face. What the Are you kidding me, bro? How do I do this PG dump command? Here we go. Give that back to me. And let's go to this bash terminal. PG dump -cc -inserts -u FreeCodeCamp universe greater than universe.sql. Here we go. Now we have this file in here. And let's copy all this. Bring it over to my GitHub. Let's go back to GitHub. Repositories, this one. We need to go to edit this. So let's edit this here. Edit. Edit this file. Let's grab all this, paste. There we go. It should be all of that. And then let's commit the changes. Update, yes. Update universe.sql. Commit directly to main. Yes, that's fine. Awesome. So now we can take our wonderful repo right here and put this in our FreeCodeCamp. And let's see if this works. Actually, I already have it in here. I did complete the project, I swear. I swear I completed it. What do I have to do? Do I have to like exit out of this? Open up, relaunch, select a new tutorial, open new workspace. I swear I completed it. Now how do I exit out? Do I have to like refresh? I might have to refresh. Maybe that's why. Control paste. Oh, yes, let's go. Let's freaking go. Finally. All right. Completed one of 5 certification projects. Looks like. All right, submit and go to next challenge. Next challenge we're doing is build 5 programs. And we're going to learn more terminal commands and how to use them with bash script by creating 5 small programs. So that should be fun. If you're looking forward to that, make sure to give the video a like, and I will see you later. All right, peace out. Bye.